Unmanned warfare: how 75% of military operations could be automated by 2030. Introduction. The landscape of military operations is undergoing a profound transformation with the advancement of unmanned warfare technologies. Projections indicate that by 2030 up to 75% of military operations could be automated, driven by innovations in drone technology, artificial intelligence (AI), and autonomous systems. This report explores the key advancements fueling this shift, the implications for military strategy, and the emerging technologies that are shaping the future of warfare. Key advancements in military drones. The global military drone market is poised for significant growth, projected to expand at a compound annual growth rate (CAGR) of 13.8% from 2024 to 2030, as outlined by Grandview Research. This growth is attributed to several technological advancements. 1. Enhanced capabilities. Improvements in endurance, payload capacity, and stealth features are redefining the capabilities of military drones. Innovations in materials science, battery technology, and miniaturization are enabling drones to fly longer distances, carry heavier payloads, and evade detection more effectively. 2. Autonomous systems. The trend towards autonomous and semi-autonomous drone systems is notable. These drones are capable of performing complex missions with minimal human intervention, thereby reducing risks to personnel and enhancing mission success rates. Advanced algorithms for navigation, target recognition, and obstacle avoidance are pivotal in this transition. 3. Network-centric warfare. Military drones are increasingly integrated with other defense systems such as ground-based radar, manned aircraft, and naval vessels. This creates a cohesive battlefield environment, enabling seamless data sharing and coordinated operations among various military assets. Emergence of tactical drones. The emergence of smaller tactical drones is reshaping military operations, particularly in intelligence, surveillance, and reconnaissance (ISR) missions. Designed for short-range engagements, these drones can be deployed rapidly and discreetly, providing real-time situational awareness in urban warfare and counterinsurgency operations. Their portability and ease of use make them indispensable for modern military strategies. Counter-drone technologies. As the deployment of military drones increases, so does the need for counter-drone technologies. These systems are essential for detecting and neutralizing hostile unmanned aerial vehicles (UAVs). Various methods, including radar, radio frequency RF jamming, and kinetic interception, are employed to protect military assets and infrastructure from drone threats, especially in asymmetric warfare contexts. Recent developments in unmanned warfare. Several companies are leading the charge in unmanned warfare technology, making significant strides in drone capabilities and applications. ZenaTech. This company is establishing a drone testing facility in Turkey for its ZenaDrone 1000 model, intended for U.S. defense and NATO applications. The facility will focus on testing drone applications for ISR, logistics, and transportation. AgEagle Aerial Systems. Recently, AgEagle received a significant order for 60 Red-HP multispectral sensors, highlighting its role in enhancing drone capabilities for government and commercial applications. Red Cat Holdings. Red Cat is collaborating with Palantir Technologies to integrate advanced visual navigation software into its drones, enhancing their autonomous operations and situational awareness in military contexts. Ondas Holdings. This company's subsidiary Aerobotics has received a purchase order from a major semiconductor manufacturer to provide ongoing aerial security and data services, showcasing the versatility of drones beyond traditional military applications. Dragonfly. Engaged in a proof-of-concept project for drone deliveries, Dragonfly aims to demonstrate how drones can ensure timely access to critical medical supplies within hospital infrastructures. Differentiation among sources. While various sources converge on the trajectory towards increased automation in military operations, they differ in focus. Some emphasize technological advancements, while others provide statistical insights into the adoption rates of AI and unmanned systems in military contexts. For example, Source 1 highlights the robust growth of the military drone market and the integration of autonomous systems, while Source 2 offers data on AI's increasing role in military applications, showcasing the multifaceted nature of unmanned warfare. Timeline of events. The advancements in unmanned warfare have been gradual but are expected to accelerate significantly throughout the 2020s. The current emphasis on autonomous drones and integrated systems is a response to the growing demand for ISR capabilities and counter-drone technologies, which are critical in contemporary combat scenarios. Conclusion. The evolution of military technology is steering warfare towards an era of increased automation. As advancements in AI and autonomous systems continue to unfold, the implications for military strategy and operations are profound. The integration of these technologies signifies a fundamental shift in how conflicts are managed and fought, with ongoing developments underscoring the urgency and importance of adapting to this new landscape. In conclusion, the future of unmanned warfare is not only about the technology itself but also about how it reshapes military doctrine, operational planning, and the very nature of conflict. As we move towards 2030, the automation of military operations promises to enhance efficiency, reduce human risk, and redefine the battlefield dynamics in ways that were once the realm of science fiction. The content highlights several counterintuitive insights regarding unmanned warfare and the automation of military operations projected for 2030. 1. Human versus machine decision-making. A common assumption is that increased automation in military operations will lead to a reduction in the need for human decision-making. However, the integration of autonomous drones and AI systems may actually create a greater demand for skilled personnel who can manage, oversee, and intervene in automated systems. This paradox suggests that while machines may take over operational tasks, the complexity of managing these systems could require a more sophisticated human workforce. 2. Perception of safety. While the automation of military operations is often associated with reducing risks to personnel, there is a counterintuitive risk that this may lead to a more cavalier approach to warfare. When human soldiers are removed from immediate danger, decision-makers might be more inclined to engage in conflict, potentially leading to more frequent military interventions. This could result in an increase in violence rather than a decrease. 3. Counter-drone technologies. As a response to increased drone use, the rise in the use of military drones necessitates the development of counter-drone technologies. This creates a cycle where the proliferation of drones leads to the evolution of countermeasures, which in turn may escalate an arms race in drone technology. The expectation that automation simplifies warfare overlooks the complexities and countermeasures that arise from increased automation. For economic implications of automation, there is a belief that automating military operations will reduce costs. However, the initial investment in advanced technologies, infrastructure, and training may be substantial. In addition, maintaining and upgrading these systems can lead to long-term financial commitments that might outweigh the anticipated savings. Thus, the economic benefits of automation may not be as clear-cut as presumed. 5. Reliance on technology. There is an inherent assumption that technological advancements will always improve military effectiveness. However, increased reliance on technology can introduce vulnerabilities such as susceptibility to cyber attacks or failures in autonomous systems during critical missions. The expectation that automation guarantees success fails to account for these potential risks. 6. Public perception and ethical concerns. The assumption that automated warfare is a more humane alternative might be misleading. The use of drones and autonomous systems can raise significant ethical concerns regarding accountability and the potential for collateral damage. The detachment of operators from the battlefield could desensitize military personnel to the consequences of their actions, leading to a more relaxed attitude toward civilian casualties. 7. Integration challenges. The integration of various autonomous systems into existing military frameworks is often viewed as a straightforward process. However, The reality is that achieving interoperability between different platforms, ensuring reliable data sharing, and adapting existing protocols to accommodate new technologies could present significant challenges, potentially delaying the expected automation timeline. These counterintuitive insights underscore the complexities and multifaceted nature of unmanned warfare and military automation, suggesting that the transition to automated military operations may not be as simple or advantageous as it appears. Important content overlooked in the report on unmanned warfare. 1. Integration of AI in military operations. While the report mentions advancements in autonomous drones and AI integration, it may overlook the nuanced implications of AI on military decision-making. As AI systems become more autonomous, the potential for errors in judgment, due to programming flaws or unexpected situations, could lead to significant consequences in combat scenarios. The ethical considerations regarding AI's role in life and death decisions are significant and warrant deeper exploration. This is especially critical as military strategies evolve toward AI-driven automation, potentially removing human oversight from crucial operations. 2. Impact on human personnel. The report discusses the reduction of risk to personnel via automation but does not delve into the broader implications for military personnel. Automation could lead to changes in military careers, training requirements, and personnel management. The human element of warfare, including the psychological impact on soldiers and the potential for a warrior class to emerge, is an area that could be profoundly affected by the shift towards unmanned warfare. Understanding these dynamics is crucial for military leadership and policymakers. 3. Counter-drone technologies. The focus on the development of counter-drone technologies is mentioned, but the strategic implications of this arms race may be understated. As military assets become increasingly reliant on drones, adversaries may develop countermeasures at a similar pace, leading to a continuous cycle of escalation in drone warfare capabilities. This dynamic could destabilize traditional military strategies and necessitate new doctrines for conflict engagement, particularly in urban and asymmetric warfare environments. For a network-centric warfare model, the report highlights the integration of drones into a network-centric warfare model but may not fully explain how this interconnectedness changes the battlefield landscape. The reliance on data sharing between various military assets can create vulnerabilities, particularly regarding cybersecurity. An adversary could exploit these vulnerabilities to disrupt operations, gather intelligence, or manipulate outcomes, thereby introducing new forms of warfare that extend beyond traditional combat. 5. Emergence of tactical drones. While the report notes the rise of smaller tactical drones, it could overlook the potential for these drones to transform not just military operations but also civilian contexts. The dual-use nature of drone technology means that advancements in military drone capabilities could spill over into civilian applications, raising concerns about surveillance, privacy, and the militarization of domestic policing. This intersectionality is significant as it raises questions about regulatory frameworks and the potential for misuse. 6. Geopolitical implications. The report primarily focuses on technological advancements without adequately addressing the geopolitical implications of widespread drone and AI adoption. Nations may feel compelled to rapidly advance their own unmanned capabilities to avoid falling behind, potentially leading to a new arms race. The strategic balance could shift dramatically, creating tensions in regions where drone technology is proliferating. Understanding these geopolitical dynamics is crucial for international relations and global security frameworks. 7. Economic impact. The economic ramifications of automating military operations could be substantial yet understated in the report. As militaries worldwide potentially reduce personnel needs through automation, this could impact defense budgets, military-industrial complex dynamics, and even local economies dependent on military bases. The transition to unmanned warfare may also create new industries and job markets focused on drone technology, necessitating a re-evaluation of workforce readiness and training programs. 8. International law and regulations. The report does not sufficiently address the legal and regulatory challenges posed by autonomous military systems. As countries develop autonomous drones, the question of accountability in the event of a malfunction or an unintended attack arises. Existing international laws governing warfare may not adequately cover the complexities introduced by AI and automation, making it imperative for international bodies to establish new legal frameworks. 9. Public perception and ethics. The ethical implications of using drones in warfare, particularly in terms of public perception, are crucial yet overlooked. The normalization of drone strikes and remote warfare could desensitize the public to the realities of conflict, affecting how societies engage with and understand military actions. Public opinion could influence military policy, and the long-term societal impacts of drone warfare may not be fully realized until much later. 10. Environmental considerations. The environmental impact of increased drone operations is not mentioned. As military drones are deployed more frequently, the potential ecological consequences, such as noise pollution, wildlife disruption, and resource consumption, could be significant. Addressing these concerns is essential for responsible military practices and sustainability, particularly in light of increasing global environmental awareness. In summary, while the report presents a comprehensive overview of the advancements and trends in unmanned warfare, several critical aspects are likely to be overlooked. Addressing these elements is significant for understanding the broader implications of automated military operations, from ethical and legal challenges to geopolitical dynamics and societal impacts. Engaging with these themes will be vital for military leaders, policymakers, and the public as we approach a future where unmanned warfare becomes increasingly prevalent. 1. Technological advancements in military drones. The rapid growth of the military drone market, projected to grow at a CAGR of 13.8% from 2024 to 2030, highlights significant advancements in drone capabilities such as endurance, payload capacity, and stealth. These improvements stem from innovations in materials science, battery technology, and miniaturization, which are essential for enhancing drone performance in complex military operations. Understanding these technologies provides insight into the future of unmanned warfare and its potential impact on military strategies. 2. Integration of autonomous systems. The increasing adoption of autonomous and semi-autonomous drones marks a transformative shift in military operations. These drones can conduct missions with minimal human intervention, improving mission success rates while reducing risks to personnel. The development of sophisticated algorithms for navigation, target recognition, and obstacle avoidance plays a critical role in this transition. Analyzing this integration reveals the strategic advantages and challenges posed by autonomous systems in warfare. 3. Emergence of tactical drones and counter-drone technologies. Smaller tactical drones designed for intelligence, surveillance, and reconnaissance (ISR) missions are becoming increasingly prominent, particularly in urban warfare and counterinsurgency scenarios. Concurrently, the rise of counter-drone technologies is essential to protect military assets from hostile unmanned systems. Exploring these dual developments emphasizes the evolving landscape of warfare, where both offensive and defensive capabilities are continuously adapting to the threats presented by drones. 4. Collaborations and developments in the defense industry. Companies like ZenaTech, AgEagle Aerial Systems, and Red Cat Holdings are at the forefront of advancing military drone technologies, showcasing the collaborative efforts between tech companies and defense entities. These partnerships enhance capabilities such as drone swarm operations and AI integration, which are crucial for modern warfare. Examining these collaborations can provide valuable insights into the future direction of military technology and its implications for global security policies. 1. The Battle of Britain 1940. This pivotal conflict during World War II involved the Royal Air Force RAF defending the United Kingdom against large-scale attacks by Nazi Germany's Air Force. The Luftwaffe. The RAF's successful use of radar technology for early warning and tracking enemy aircraft is considered one of the first instances of automated warfare technology influencing military operations. The radar system allowed for real-time intelligence gathering and coordinated defensive strategies, demonstrating how technological advancements can significantly alter the course of military engagements. 2. The Gulf War 1990 to 1991. The Gulf War showcased the extensive use of precision-guided munitions and satellite reconnaissance, marking a shift towards technologically advanced warfare. The U.S. military's use of drones for reconnaissance missions such as the RQ-1 Predator allowed for real-time surveillance over enemy positions and the gathering of critical intelligence without putting pilots at risk. This conflict set a precedent for the integration of unmanned systems in military operations, emphasizing the potential for automation in combat scenarios. 3. The War on Terror post-9/11. The U.S. and Allied forces operations in Afghanistan and Iraq saw the increased deployment of unmanned aerial vehicles (UAVs) for surveillance, reconnaissance, and targeted strikes. Drones like the MQ-9 Reaper became central to military strategies, allowing for missions to be conducted with minimal human intervention. The reliance on drone technology in asymmetric warfare against non-state actors highlighted the evolution of military tactics and the growing role of automation in operational planning and execution. This era has raised ethical and strategic questions about the use of unmanned systems in combat, influencing military doctrine and policy. Future outlook on unmanned warfare, predictions for 2030. As we approach 2030, the landscape of military operations is poised for a dramatic transformation driven by advancements in unmanned warfare technologies. Predictions suggest that up to 75% of military operations could be automated, fundamentally altering how conflicts are conducted. Here are key areas of focus and anticipated developments. 1. Rapid growth of military drone capabilities. The military drone market is forecasted to experience significant growth with a compound annual growth rate CAGR of 13.8% from 2024 to 2030. This expansion is expected to be fueled by enhancements in drone endurance, payload capacity, and stealth technology. Innovations in materials science and battery technology will enable drones to operate longer and carry heavier loads, while miniaturization will make drones more effective in diverse combat scenarios. 2. Increased adoption of autonomous systems. The shift toward autonomous and semi-autonomous drones will gain momentum, enabling these systems to execute complex missions with minimal human intervention. This move will not only reduce the risk to personnel but also improve mission success rates. Sophisticated algorithms for navigation, target recognition, and obstacle avoidance will be crucial to this transition. By 2030, we can expect a significant portion of reconnaissance, surveillance, and even strike missions to be carried out by autonomous drones. 3. Emergence of tactical drones in urban warfare. The development and deployment of smaller tactical drones designed for short-range missions will become more prevalent. These drones will be essential for intelligence, surveillance, and reconnaissance ISR operations, especially in urban warfare and counterinsurgency contexts. Their ability to provide real-time situational awareness will be invaluable in fast-paced, densely populated environments. 4. Integrated network-centric warfare models. Military operations will increasingly adopt a network-centric warfare model where various platforms, including drones, manned aircraft, and naval vessels, are interconnected. This integration will enhance data sharing and coordination, allowing for more effective joint operations. By 2030, we can expect a seamless operational environment where drones serve as critical nodes in a larger, interconnected battlefield network. 5. Advancements in counter-drone technologies. As the use of military drones escalates, so too will the need for counter-drone technologies. These systems will focus on detecting, identifying, and neutralizing hostile drones using methods such as radar, RF jamming, and kinetic interception. The rise of asymmetric warfare, where non-state actors utilize commercial drones for attacks, will drive innovation in counter-drone solutions, ensuring military assets remain protected. 6. Partnerships between tech companies and defense entities. Collaboration between technology firms and defense organizations will accelerate the development of advanced drone systems. Companies like ZenaTech, AgEagle, and Red Cat Holdings are already leading the charge in creating innovative drone solutions. By 2030, we can anticipate many more partnerships that leverage cutting-edge technologies including artificial intelligence and quantum computing to enhance drone capabilities and operational effectiveness. 7. Regulatory and ethical considerations. As unmanned warfare becomes more prevalent, ethical and regulatory challenges will emerge. Issues concerning accountability, the rules of engagement, and the potential for autonomous weapons systems to operate independently will provoke intense debate. By 2030, militaries around the world will need to establish guidelines and frameworks to address these concerns while harnessing the benefits of automation. 8. Impact on military employment and training. The automation of military operations will inevitably affect personnel training and employment. By 2030, military training programs will need to adapt to prepare soldiers for a battlefield increasingly populated by automated systems. While some traditional roles may diminish, new opportunities will emerge in areas such as drone operation maintenance and cyber defense. Conclusion. The future of unmanned warfare appears set to redefine military operations fundamentally. By 2030, advancements in drone technology, automation, and integration will lead to a battlefield where unmanned systems play a central role. As these technologies evolve, they will not only enhance operational efficiency and effectiveness but also pose new ethical and strategic challenges that will require careful consideration and proactive management. The military landscape will undoubtedly be shaped by these advancements, leading to a new era of warfare characterized by automation and intelligence-driven operations.